Hello, so we are going to start into the first chapter for Math 120, and that is the review chapter, and they call it Chapter R. So, let's talk about Chapter R, and in this chapter it's talking about functions, graphs, and models. In the very first section of this chapter, we are going to be talking about graphs and equations. So here's the thing. This particular chapter should be a review. I do not want to insult your intelligence. I'm sure you remember how to do some of this graphing, and as we walk through it, you are going to remember even more of it. So let's just get started and see what you do remember. So the first thing we are going to graph is this equation, y equals negative 3x plus 1. So first off, I want to see what you remember. If you take a look at this equation, you should be able to tell me what the graph of this will be. So if both exponent on x and y are both 1s, recall that means this is a linear equation. And so if it's a linear equation, then when you graph it, you will end up with the graph of a line. Hence, you see the word line within the word linear. So, there are three different ways of graphing a linear equation. We're just going to talk about one of them. And the one we're going to talk about is called the XY chart, or XY table, whichever you prefer. It's the same thing. So, 2 points make a line. That's very true. In our world, we're going to have 3 points make a line. Just in case we make an arithmetic error, we can figure that out very quickly when we connect the dots. So I like to choose three numbers, and I'm going to make it easy on myself, but I want to choose a positive number, a negative number, as well as the neutral number. So I always like to choose 1, 0, and negative 1 for my x's. So I am going to take x and I'm going to plug it in. I'm going to plug it into what y equals. Remember, the equal to sign says that whether they look like it or not, these two sides are exactly the same. So I'm going to take negative 3 and multiply it by the 1 and then add 1 to it. And when I do that, I end up with negative 2. So the actual point that we are going to graph is the x point, or the x coordinate, and then the y coordinate. So 1, negative 2. The next x value is 0. I'm going to do the exact same thing. Into the y, which is found by doing negative 3 times x, which in this case is 0, plus 1, we are just going to get 1. So the point is 0, 1. Remember, x, y. And last but not least, I am going to take the negative 3 multiplied by the x in this case, which is negative 1, add 1 to it, and when I do that, I am going to get 4. So the point in this case is negative 1, 4. Now that we actually have our 3 points, let's get our coordinate system up here. And you can make yours as neat as you'd like and as big as you like. But I know I only have 3 points to graph. And the first point that we are going to graph is the point 1, negative 2. So 1, negative 2. The next point is 0, 1. And the third point is negative 1, 4. If we connect these 3 dots, or I should say when we connect these 3 dots, gratefully we must have done everything correctly, because we get a line, which is exactly what we're supposed to get. And this line is called y equals negative 3x plus 1. Cool. Remember? So, now that we've graphed a linear equation, let's work with another linear equation. This first one that we graphed was in a very neat order. It was set up, if you recall, as y equals mx plus b. It was very easy to plug numbers in. But that doesn't always happen. They're not always set up so nicely for us to plug in. So, and in some occasions, we have to do some rearranging. So, for instance, if I write this equation up, problem number 2, by the way, 8y minus 2x equals 4. If you notice, this one's not set up as nicely as the last one. So, we might have some rearranging to do. Now, there is another option of graphing a linear equation. By the way, remember what I mentioned? You know this is a linear equation because if you take a look at it, the power on x and y, in this case, are both 1s, which means it is going to be a linear equation. So when I graph it, it's going to be the graph of a line. So, instead of plugging in points for x and see what comes out for y, or even vice versa, plug in points for y and see what comes out for x, I am going to remind us of another way that we can graph this. This particular equation is set up perfectly for us to find the x-intercept and the y-intercept. Okay, so let's go that route instead because that's going to be much easier for this equation. So recall, to find the x-intercept, you must allow y to equal 0. When y equals 0, let's see what the equation looks like. Obviously, we're going to take 8 times y, which is 0, minus that 2x equaling 4. The result so far looks like negative 2x equals 4. Divide both sides by negative 2. I get negative 2. So, the point I have is x first, which is negative 2, y second, which is 0. Got it. Let's do the second one. To find the y-intercept, recall, you have to let x equal 0. When you let x equal 0, your equation starts looking like 8y minus 2 times 0 equaling 4. Obviously, 2 times y is just 0, so I'm left with 8y equaling 4. And when I finish solving, I end up with y equaling 4/8, a fraction, yay! And I reduce it and I get a half. So, x first, which is 0, y second, which is a half. Cool. So far, so good? This is a line. 2 points make a line. I have 2 points. I don't need a third point. Okay? That was just to check my arithmetic on the last problem. So, again, let's get our coordinate system up here. And we have 2 points to plot. We have negative 2, 0. And then we have 0, 1/2. Gratefully, the fraction was 1/2. That makes it very easy to plot. When we connect these 2 points, assuming that I can draw a reasonable line, okay, we get a line, which is exactly what we're supposed to get, and this line is 8y minus 2x equals 4. How you doing? So far, so good? Wonderful. So, we are going to continue, but let's switch it up a little bit. Instead of graphing a line, let's talk about a second degree equation. Okay? A second degree equation is also known as a quadratic equation. And a quadratic equation has a power of 2 on it. So, for instance, this is definitely a quadratic equation. In this case, the second power is on the variable y, not x. That's okay, it doesn't matter. It still means I'm not going to get a line. So, when we graph this, we are going to, or I should say my suggestion is we graph it like we graphed the very first problem. Use our XY table. But you have to be careful, because in this case, instead of plugging in for x, I'm going to plug in for y, because the x is the one by itself. Y is the one that everything's being done to. You're going to square it first, and then you're going to add 2. So I'm going to start plugging numbers in for y. And I'm going to choose the exact same 3 numbers. I'm going to choose 1, 0, and negative 1, because that makes life easier. I can handle 1s and 0s. But I like positive, neutral, and negative, because I need to find out what's happening in all 3 ends of the world, so to speak. So, when I plug in 1 for the y value, x now is going to be determined by squaring the 1 and then adding the 2. And when you do that, you get 3. Which means the point that you get, and I ran a little bit out of room on this side, so I'm going to write the point on this side. We are going to get x first, which is 3, y second. Okay? Now I do the same thing for the next 2 points. Plug in the y value, square it, add 2. I'm going to get just 2 there, which means my second point will just be 2, 0. The third point, we are going to square the y, add 2, and I get 3 again. So my third point is 3, negative 1. So, when I draw my coordinate system, and I am going to now plot these 3 points. 3, 1 is the first point. 2, 0 is the next one. 3, negative 1. Okay? So notice these 3 dots, we're connecting them this way. And if you're not certain how it's still going to go from there, well, then we can plug in some more points for y. Additional points I would plug in would be a positive 2 and a negative 2, just to see what it's doing even more if you're not sure from here. So if I plug in positive 2, I'm going to square it, I'm going to add 2, that's going to give me 6. So I end up with a new point of 6, 2. And if I plug in the negative 2, first thing I'm going to do is square it, add 2, and that is also going to give me 6, which my new point is 6, negative 2. So 3, 4, 5, I need one more. 6, 2, and 6, negative 2. Here are the additional points, which means we can tell it is going to be what some people like to call a sideways parabola. So, hopefully that refreshed your brain on how to graph linear equations as well as second degree equations. Have fun with homework.